Now, in this class, let us talk about graphical user interface programming with Swings. The origin and design philosophy of Swings. Let us see what exactly this Swing is. Swing is a part of Java Foundation class that is used to create window based applications. It is built on the top of AWT, that is Abstract Windowing Toolkit API, and entirely written in Java. So unlike AWT, Java Swing provides platform independent and light-weighted components. So AWT is platform dependent, whereas Swing is platform independent. The Swing programming is written entirely in Java. So the javax.swing package provides classes for Java Swing API such as JButton, JTextField, JTextArea, JRadioButton, JCheckbox, JMenu, JColorChooser, etc. So difference between AWT and Swing. There are many differences between java.awt and Java Swing. The differences are given here under Java AWT under Java Swing. AWT components are platform dependent. Java Swing components are platform independent. AWT components are heavyweight. Swing components are lightweight. AWT does not support pluggable look and feel. Swing supports pluggable look and feel. AWT provides less components than Swing. Swing provides more powerful components such as tables, lists, scroll pans, color chooser, uh, tabbed pane, etc. AWT does not follow model view controller, where model represents data, view represents presentation, and controller acts as interface between model and view. Swing follows model view controller. Let us see what is JFC. Java Foundation classes are a set of GUI components which simplify the development of desktop applications. Components and containers. They are given below. Object, component, component has container, J component, container has window, panel, panel has applet, window has frame, dialog, J component has J label, J list, J table, combo box, J slider, J menu, abstract button, J button. Commonly used methods of component class. So the methods of component class are widely used in Java Swing. There are given below. Public void add component C adds a component on another component. Public void set size, integer width, integer height. It sets the size of the component. Public void set layout, layout manager integer, sets the layout manager for the component. Public void set visible boolean b, sets the visibility of the component if it is by default false. Now Java, let us see the Java Swing example. There are two types. There are two ways to create a frame. One is by creating the object of frame class. Another one is by extending frame class. We can write the code of Swing inside the main constructor or any other method. A simple Java Swing example. Let us see. Let's see a simple Java Swing example where we are creating one button and adding it on the JFrame object inside the main method. Import javax.swing.star public class first swing example. public static void main string arguments, jframe f equal to new jframe, creating instance of jframe, j button b equal to new j button, click, creating instance of j button, b dot set bounds 130 100 x-axis y-axis width and height, f dot add b, adding buttons in frame, f dot set size 400 width and 500 height, f dot set layout using no layout managers, f dot set visible, making the frame visible. So when we execute the above program, the output will be looking like this. Now let us see the layout managers. The layout managers are used to arrange components in a particular manner. The Java layout managers facilitates us to control the positioning and size of the components in GUI forms. Layout manager is an interface that is implemented by all the classes of layout managers. There are the following classes that represent the layout managers: java.awt.border layout, java.awt.flow layout, java.awt.grid layout, java.awt.card layout, java.awt.grid bag layout, javax.swing.box layout, javax.swing.group layout, javax.swing.scrollpan layout, javax.swing.spring layout, etc. Border layout is used to arrange the components in 5 regions: north, south, east, and west, and center. Each region may contain one component only. It is the default layout of a frame or window. The border layout provides 5 constants for each region: public static, final, integer north, integer south, integer east, integer west, integer center. Constructors of border layout class. Border layout creates a border layout but with no gaps between the components. Border layout integer sgapp, integer vgapp creates a border layout with the given horizontal and vertical gaps between the components. Example of border layout class using border layout constructor, border.java file name. So import java.awt.star, import javax.swing, public class border, jframe f, border f equal to new jframe, j button b1 equal to new j button north. The button will be labeled as north, and likewise it will be labeled as south, east, west, and center. F dot add b1 border layout. b1 will be placed in the north direction. Likewise, south button will be placed in the south side. b3 will be displayed in the east direction. b4 in the west direction. b5 in the center. So f dot set size 300 300. F dot set visible true. So public static void main string arguments new border. So when the above program is executed, the output is event handling. So let us see what exactly the event. So change the state of object is known as event. That is, event describes the change in the state of the source. Events are generated as a result of user interaction with the graphical user interface components. For example, clicking on a button moving the mouse, entering a character through keyboard, selecting an item from the list, and scrolling the page are the activities that cause an event to occur. So, types of events. The events can be broadly classified into two categories. Foreground events. These events require direct interaction of the user. They are generated as consequences of person interacting with the graphical components. In the graphical user interface, for example, clicking on a button, moving the mouse, entering a character through keyboard, selecting an item from the list, scrolling the page, etc. Background events. These events require the interaction of the end user. Operating system interrupts, hardware or software failure, timer expiration, and operation completion are some examples of background events. Then, what is an event handling? Event handling is the mechanism that controls the event and decides what should happen if an event occurs. This mechanism has a code which is known as an event handler that is executed when event occurs. Java uses the delegation event model to handle the events. This model defines the standard mechanism to generate and handle the events. The delegation event model has the following key participants. Source. The source is an object on which the event occurs. Source is responsible for providing information of the occurred event to its handler. Java provides us with classes for the source object. Listener. It is also known as event handler. The listener is responsible for getting a response to an event. From the point of view of Java implementation, the listener is also an object. The listener waits till it receives an event. Once the event is received, the listener processes the event and then returns. So the benefits of this approach is that user interface logic is completely separated from the logic that generates the event. The user interface element is able to delegate the processing of an event to a separate piece of code. In this model, the listener needs to be registered with the source object so that the listener can receive the event notification. This is an efficient way of handling the event because the event notifications are sent only to those listeners who want to receive them. So, the basic steps that are involved in event handling. Step 1 is the user clicks the button and then event is generated. Step 2 is the object of concerned event class is created automatically and information about the source and the event get populated within the same object. Step 3 is event object is forwarded to the method of the registered listener class. Step 4, the method gets executed and returns. Points to remember about the listener. In order to design a listener class, you have to develop some listener interfaces. These listener interfaces forecast some public abstract callback methods which must be implemented by the listener class. If you do not implement any of the predefined interfaces, then your class cannot act as a listener class for a source object. Callback methods, these are the methods that are provided by the API provider and are defined by the application programmer and invoked by the application developer. Here the callback methods represent an event method. In response to an event, Java JRE will fire callback method. All such callback methods are provided in listener interfaces. If a computer wants some listener to listen of its events, the source must register itself to the listener. So let us see the event handling example. So create the following Java program using any editor of your choice. Say swing com GUI so, swing control demo package tutorial. So import java.awt.star, import java.awt.event.star, import javax.swing.star, public class swing control demo, private JFrame, mainframe, private JLabel, head label, private JLabel, status label, private JPanel, control panel, public swing control demo, which is a constructor, prepare GUI, public static void main, string arguments, swing control demo equal to new swing control demo, swing control demo dot show event demo, private void prepare GUI, mainframe equal to new JFrame Java Swing example, mainframe dot set size 400 400, mainframe dot set layout new grid layout 31, header label equal to new JLabel center, status label dot set size 350 100, mainframe dot add window listener new window adapter, public void window closing window event system dot exit, control panel equal to new JPanel, control panel dot set layout new flow layout, mainframe dot add header label, mainframe dot add control panel, mainframe dot add status label, mainframe dot set visible true. So public void show event demo, header label dot set text control in action button, J button OK button equal to new J button OK, J button submit button equal to new J button submit, J button cancel button equal to new J button cancel. So OK button dot set action command OK, submit button dot set action command submit, cancel button dot set action command cancel, OK button dot add action listener new button click listener. So likewise the control panel mainframe dot set visible, so public private class button click listener implements action listener, public void action performed action event E, string command equal to E get action command, if command dot equals OK, status label dot set text OK button clicked, else if command dot equals submit, status label dot set text submit button clicked, else status label dot set text cancel button clicked. So compiling the program using the command prompt, Java C swing control demo, it means the compilation is successful using the following java.com swing control demo, you will get the output as